Imagine your next flight. Except the pilot isn't just a person. It's also a Silicon Valley chip making these split-second decisions. We're talking about incredibly specialized, mission-critical AI moving into the skies. But at the same time, we're seeing new research that's exposing these surprising, almost ghost-like memory flaws in the very same kind of AI models that run our daily lives.
And welcome back to the deep dive. Today's mission is really about synthesizing a stack of recent sources that highlight that exact tension. These explosive technical breakthroughs happening right alongside some really fundamental safety challenges.
We're charting a course through the most important shifts in the industry right now.
Yeah, we've got 3 core segments for you today. First up, we're dedicating serious time to that engineering breakthrough in the skies, the huge Archer and NVIDIA collaboration on autonomous air taxis.
And what that ultra-low latency compute actually means for aviation safety.
Exactly. Then second, we'll move from the skies down to the keyboard. We're going to cover the changing tools landscape. So why prompt engineering is evolving, the rise of these specialized productivity agents, and some really critical geopolitical shifts in the hardware war. And finally, we're doing a deep dive into a crucial safety alert. A Stanford study just proved leading LLMs are memorizing entire books verbatim and how easily you can just bypass their safety filters.
Okay, let's unpack this.
Let's start with that massive engineering challenge up high. So, Archer Aviation, they made huge headlines at CES 2026. They announced they're integrating NVIDIA's new IGX Explorer platform into their next-gen air taxi.
And this integration, it's a huge jump. We've seen IGX Thor used in places like hospitals for complex surgical automation and in these high-precision factories.
Right, very regulated environment.
Very. But moving into passenger aviation, that's a completely different level of regulatory and safety challenge. It just demands mission-critical, instantaneous decision-making every single second of the flight.
And that's why the scale of this is so telling. Archer isn't just running a few demos in a hangar somewhere. They have their own dedicated airport, which is basically becoming ground zero for real-world AI aviation testing. They're building this whole autonomous ecosystem from the ground up.
So if SOAR is the AI brain, what's the nervous system? You synthesize this whole complex integration into 3 foundational pillars for us.
I did. So the first one is all about pilot safety and predictive awareness. This system is constantly running simulations in the background, providing real-time alerts, smart flight suggestions, all to improve human decision-making.
So it's like an always-on co-pilot.
Exactly. It's seeing things the human pilot might miss, especially in these really high-density airspaces.
That makes sense. Mitigating human error is key. But how does this level of AI integration change the pilot training requirements? Are we augmenting human skills here? Or are we on a path to eventually replace certain skill sets entirely?
For now, it's an augmentation, but a necessary one. Think about the speed you need for real-time sensor fusion. The plane's taking in LiDAR data, radar, internal diagnostics, external weather.
All at once.
All at once. And you need nanosecond-level processing to make predictions from all that. That ultra-low latency is the entire point. If the plane detects, say, a wind shear or an unknown drone, it needs to plot a new, safe trajectory instantly.
That really puts the safety component into sharp focus. Okay, what about Pillar 2?
The second is seamless airspace integration. This is just critically important because these new air taxis have to coexist with the old world of aviation, right? So the AI handles all the dynamic traffic-aware flight routing. It makes sure it plays nicely with all the legacy air traffic control systems we already have. It's basically the translation layer between future tech and current regulation.
And the third pillar is the one that really sets the stage for the future, right?
Exactly. The third is autonomy-ready controls. This entire integration, it's all about building the core compute layer that's necessary for future semi-autonomous or, eventually, fully pilotless systems. Pairing Thor's compute with Archer's avionics, that's the digital backbone for the ultimate vision.
The stakes are just impossibly high. When we talk about safety-critical computing at that level of scale, pushing, 1 billion queries across an entire air traffic system, you have to ask, are the benchmarks for testing even fully developed yet? It really is a moment of wonder at the engineering complexity.
It forces us to ask tough questions about trust. Beyond the air taxi itself, what's the single biggest challenge this low-latency compute solves for future air travel?
It solves the hard problem of fitting autonomous routing into our old, existing air traffic rules.
And that high-stakes focus on safety in the skies. It's such a sharp contrast to how casually we often use AI in our daily lives. And speaking of daily use, let's move from the cockpit back down to the desk, because how we even talk to AI is changing fast.
Right. Our sources are indicating that the finicky art of crafting the perfect instruction set, what we call prompt engineering, is now facing some pretty rapid disruption.
That's right. And prompt engineering, to put it simply, is just the skill of writing precise instructions to get the exact result you want from an AI model. For a long time, it really felt like black magic.
And that magic is changing. Anthropic has released a new structural trick using XML tags for much better control over their models. And we're seeing reports that this dramatically outperforms the older, messier methods.
It's a huge technical insight. The older methods, like context dumps, are basically just pasting thousands of words of unstructured text into the prompt and just hoping the model figures it out.
Right.
XML tags standardize the input for the model. It makes its attention mechanism way more efficient, less likely to get lost in the noise. It's like stacking Lego blocks of data in a structured way instead of just throwing a pile at the model.
I still wrestle with prompt drift myself. Models start ignoring my specific instructions after a few conversational turns. So seeing new structural techniques like XML tags is a massive relief.
But does the shift toward these structural inputs mean that large enterprise-grade AI is becoming fundamentally less accessible to the casual user who doesn't want to learn a markup language?
That's a key tension. But ironically, that complexity is also driving the creation of tools that simplify everything else. And that simplification is fueling a real emergence of practical, non-technical AI usage.
Less Python, more delegation.
Exactly.
We've seen these incredible guides surfacing, things like building automated workflows to stop you from chasing messy data or clearly defining the 4 AI agents a non-technical person needs to delegate, like 90% of their routine tasks.
And we have the proof of concept. Peter Yang's 47-minute Claude Code demo. It showed a non-developer using that tool to genuinely run her entire life. Scheduling, managing finances. AI is moving way beyond just generating marketing copy. It's becoming an integrated workflow manager. The specialized experiences are also key for broad adoption. We've got new dedicated wellness support with ChatGPT Health, and Google Classroom can now turn any lesson into a specialized podcast. You can specify the topic, the speakers, the style. These targeted tools are immediate wins.
So we've discussed how the user experience is changing, but that experience is shaped by these massive forces behind the scenes. Let's talk about the geopolitical hardware wars and some crucial safety issues defining the industry's foundation.
Switching to geopolitics, the ground is definitely shifting beneath the hardware market.
It absolutely is. China is reportedly asking its domestic tech firms to pause orders for the powerful NVIDIA H200 chips. And the strategic goal is pretty clear. They want to steer buyers toward domestic AI chip alternatives to build self-sufficiency. This move has huge global supply chain implications.
And it's important context here that each H200 export still requires U.S. government approval, and there's no set timeline for that complex process, so it keeps pressure on both sides.
We're also seeing consolidation in the talent war. OpenAI just acquired the Convogo team. That's its 9th acquisition this year. This team used to help human coaches scale their work, but now they're shifting their focus entirely to building AI cloud tools for core infrastructure.
So the top talent is being pulled into the foundational model architecture.
Yep.
And that rapid consolidation and technological advance brings us right back to safety. We have to address the crucial issue around content moderation.
Right. Reports have shown that X is seeing a staggering volume, something like 6,700 or more AI-generated illegal images per hour, specifically attributed to the Grok platform.
That number, it's staggering.
Yeah.
It just demonstrates how current moderation systems, even with advanced AI, just cannot keep pace with generative output.
No chance.
And if the global nature of the internet stalls legal action because of different jurisdictions and slow regulatory response, we're left in a really difficult spot.
And that's where the pressure is focused right now. Global regulators are pressing XAI over this issue, but legal limitations in different countries are stalling any truly effective unified action. It just highlights the difficulty in regulating real-time, high-volume content generation globally.
So given all these regulatory challenges, geopolitical shifts, and application changes, which trend tells us more about the immediate future of AI use?
The shift toward dedicated, specialized agents. Things like the new Google AI inbox. It shows immediate consumer integration and a desire to delegate specific, small tasks rather than rely on one big generalist LLM for everything.
That's a powerful sign that the specialization era is upon us. Okay, now for the most concerning news in our sources and perhaps the biggest challenge to the industry's current legal defense, a major breakthrough on LLM vulnerabilities.
Yeah, this is a profound finding from a new Stanford study, and it directly challenges the industry consensus on filtering and data handling.
The core revelation. This study proved that production-grade LLMs, the ones people are paying for and relying on right now, still memorize and leak near-exact copyrighted book text. And they tested every major player: Claude, GPT, Grok, and Gemini.
And the specific data is just startling because the recall rate is so high and so consistent. Claude 3.7 Sonnet, for example, it hit a 95.8% text extraction recall rate on certain books. That's virtually perfect, consistent memorization.
What makes this study so concerning isn't just the leakage itself, but how easily the model's internal filtering systems, the supposed guardrails, were just bypassed.
The technique they use to break the safety layers is deceptively basic. It's like a digital shoulder tap. It's basically the three-step process. One, give the model the opening line of a copyrighted book.
Okay.
Two, ask it to continue the text. If it initially refuses, which the guardrails are designed to make it do, you just reword the prompt very slightly until it complies.
And that's it.
That's it. And three, the model then often just delivers high-quality verbatim text.
So the result is consistent, high-quality memorization across multiple books and all four of the major production models.
Correct. And this suggests that the safety layers are not true, hard constraints. They're merely soft suggestions. The underlying data is just stored perfectly intact, waiting for the right prompt format to unlock it.
If these models leak exact book text this consistently, it totally changes the legal calculus. It makes arguments about fair use training, the idea that models are only absorbing general patterns, much harder for companies to defend in court.
Yeah, you can't claim you're summarizing if you can spit out entire paragraphs verbatim.
Right. And filters applied on top clearly don't fix the memorization that's buried inside the model's weights.
So if filters fail this easily, what does this finding suggest about trusting AI models with proprietary or sensitive corporate data?
Well, if it remembers books, it likely remembers sensitive data, which is just a fundamental security and legal risk for any company using these tools internally. So let's connect these threads. The overarching theme here is this fascinating paradox that really defines this moment in AI history. We're simultaneously building these revolutionary safety-critical AI systems, like the architecture for air taxes, demanding perfection, while also exposing these fundamental, profound flaws in foundational models around privacy and safety filters.
It's the tension between aspiration and reality. For the knowledge-seeking listener, we've got three key takeaways from today's sources. First, the future of mobility requires ultra-low latency, mission-critical compute. This isn't optional. It's the core safety requirement for systems like Archer and Thor.
Second, the practical AI toolkit is rapidly changing. Prompt engineering skills are shifting, being replaced by structural inputs like XML, and these specialized agents are taking over our daily high-volume delegation tasks.
And third, LLM memory is a profound, exploitable vulnerability. This discovery really undermines current legal defenses and challenges the core assumptions we all have about AI safety and data privacy.
We've seen that the filter layers fail when they're just slightly challenged, proving the data is stored intact. So given this memory flaw, the next question is personal. If the model holds proprietary corporate data and the legal defense for training is eroding, what immediate steps should IT departments take this week to audit their internal LLM deployments?
Something to ponder as you navigate this rapidly changing technological landscape.
Thank you for joining us on the Deep Dive. We'll see you next time.